All right, so the next thing we want to look at is proving the identity that tan A plus B is equal to tan A tan B divided by 1 minus tan A tan B. All right, to do this, I'm going to start, well, with a proof, you have to always start from the left and go to the right. That tan A plus B is the same as saying sine A plus B over cos A plus B. So then this now, let's expand sine A plus B into sine A cos B plus cos A sine B. And let's expand cos A plus B into cos A cos B minus sine A sine B. The next thing I'm going to do is I'm going to divide the numerator and the denominator by cos A cos B. I'm going to divide the numerator and the denominator by cos A cos B. So if we do that, we're going to end up with sine A cos B divided by cos A cos A cos B plus cos A cos B over, that's cos A sine B over cos A cos B. So what I've just done is I've just divided the numerator by cos A cos B, and I'm going to do the same thing with the denominator. This is cos A cos B divided by cos A cos B minus sine A sine B divided by cos A cos B. So what we'll end up with is, over the left, we have in numerator tan A, because cos B is going to cancel cos B, and cos A cancels cos A. So this is a plus the tangent of B, and this is all over 1 minus sine A over cos A is tan A, and sine B over cos B is tan B. So a plus should be there here. I think when I wrote the tan, I forgot to put the plus. So if you had difficulty solving it because of that, it's my fault. All right, now along with this, we need to prove that we need to show or be able to show that tan A minus B is actually equal to tan A. I think it's what? minus tan B over 1 plus tan A tan B. All right, so we need to also show that this is true. Let's change our color ink. Using what? Using the identity tan A. So this is tan A plus minus B. So if we use the tan A plus B identity, if we use the tan A plus B identity, we're going to end up with tan A plus the tangent of minus B over 1 minus tan A times the tangent of minus B. But the tangent of minus B is equal to minus the tangent of B. The tangent of minus B is equal to minus the tangent of B. So this is equal to tan A plus minus tan B all over 1 minus tan A times minus tan B. So this becomes tan A, a positive times a negative is a negative, minus tan B all over 1, a negative times a negative is a positive, tan A tan B. So tan A minus B is equal to tan A minus tan B divided by 1 plus tan A tan B. Tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. Example 36. And then we'll have a go at 37 as well. We're to show that the tangent of pi minus theta is equal to minus tan theta. Well, the tangent of A minus B is equal to tan A minus tan B over one plus tan A tan B. So it means, therefore, that the tangent of pi minus theta would be equal to tan pi minus the tangent of theta all over 1 plus tan pi, the tangent of theta. I think that the tangent of pi is 0. The tangent of pi is 0. So what we have here is 0 minus tan theta over 1 plus 0 times tan theta. So what we end up at the top is just minus tan theta. And down by the bottom, the only thing we have is 1. So this is just minus tan theta. All right, so next we're going to move to example 37. Example 37 says that the sine of the angle theta is equal to 1/3. Sine is opposite over hypotenuse. So the side, if you put theta in a right angle triangle, the side that would be adjacent to theta would be the root of 9 minus 1, which would be 8. The root of 8 which is actually 2 root 2. Root of 8 is 2 root 2. And so we're asked to determine what is the tangent of theta. All right, I guess we can look at this two ways. We could say that tan theta plus pi by 4 is the same as saying cos, sorry. This is one way of looking at it. I'm sure it's not the only way. It's the same as saying sine theta plus pi by 4 over the cos of theta plus pi by 4. This is one way of looking at it. So using our compound angle formula, this should be sine theta. All right, let's see. Yeah, sine theta cos pi by 4 plus the cosine of theta, the sine of pi by 4. And this is over, again, using our compound angle formula. This would be over the cosine of theta, the cosine of pi by 4, minus the sine of theta, the sine of pi by 4. So as I said, I really doubt that this is the only way to do this. The cosine of pi by 4 is root 2 over 2. So this is sine theta times root 2 over 2 plus cos theta times root 2 over 2. Because the sine of pi by 4, and the cosine of pi by 4 is the same, which is root 2 over 2. Down by the bottom, in the denominator, I have the cosine of theta, root 2 over 2, minus the sine of theta, root 2 over 2. All right, I can easily determine what the sine of theta is. Actually, I know that already. The sine of theta, this is given, is 1/3, and the cosine of theta is 2 root 2 over 3. So I can put these in. So this is 1/3 times root 2 over 2 plus 2 root 2 over 3 times root 2 over 2. That's the numerator. Divided by 2 root 2 over 3, which is the cosine of theta, times root 2 over 2 minus the sine of theta, which is 1/3, times root 2 over 2. So what we have here is root 2 over 6 plus 2 times 2 over 6. Because root 2 times root 2 is 2, and then you're going to have 2 times 2 over 6. Divided by 2 times 2 over 6, which is 4 over 6, minus root 2 over 6. This would be 2, sorry. This is root 2 plus 4 over 6 divided by 4 minus root 2 over 6. All right. And why am I going to feeling that I went through all that trouble and I'm not going to get this? And that maybe some other approach would have been better. Or I could be wrong. This is root 2 plus 4 over 6 times 6 over 4 minus root 2. So obviously the 6 is cancelled. And I'm going to have to take this up here. I'm going to change the color ink as well. So now what I have is 2 plus root 2 plus 4 over 4 minus root 2. Next, I'm going to conjugate by multiplying the numerator and the denominator by the conjugate of the denominator, which is 4 plus root 2, 4 plus root 2. All right, so up top, I'm going to get what? 4 root 2. Root 2 times root 2 is 2, plus 4 times 4 is 16. 4 times root 2, it's actually the square of it. 4 times root 2 is 4 root 2. Down by the bottom, I have 16 minus 2. Up top, I have 18 plus 8 root 2. Down by the bottom, I have 14. All right, up top, let's factor out 2. If I do, I'm going to get, so that's 2 over 14. Then I'm going to have 9 plus 4 root 2. And so this works out to be 1 over 7 into 9 plus 4 root 2. So let's see if that's what they said we should prove. And yes, that's exactly what they said we should prove. And we did it. Let's try and see if we can get a view of the entire thing. All right, so this is example 34.